Welcome to Serene Science, a place for stress-free learning. If you need a break from studying, I have a series of guided meditations on this channel that can help you relax and refocus. Check those out if you wish. In this video, we're going to look at how to count the number of atoms in a given chemical formula. Let's look at a couple of examples. So in this first question, it asks, how many hydrogen and oxygen atoms are in the following? And we're going to start with the formula on the left, which is H2O. You might be familiar with this. It's the chemical formula for water. And if we look at that formula, we see H for hydrogen and O for oxygen. We also see that there is a 2 subscript after the H. What this means is that we have 2 hydrogen atoms. Notice that after the O, nothing is written. If nothing is written after the element in a formula, that means we just have 1. So 1 oxygen atom. Let's look at 2H2O. This should look really similar, but now we have the number 2 in front of our formula. This number 2 is called a coefficient, and you'll run into this when you're balancing chemical equations or when you're calculating mole ratios when you're doing stoichiometry problems. And what this coefficient means is that I actually have 2 H2O molecules. So this is going to change the number of hydrogen and oxygen atoms. So since there are 2 H2O molecules, I now have a total of 4 hydrogen atoms and a total of 2 oxygen atoms. I can see that from the way that I wrote those 2 water molecules, H2O molecules. Alternatively, I can take the coefficient in front of the formula and multiply it by the subscript after the element. So for example, hydrogen has a subscript of 2 written after it. So I take 2 times the 2 coefficient in front to give me a total of 4 hydrogen atoms. For oxygen, nothing is written, so there's an understood 1 to be there. So I take that 1 and multiply it by the coefficient of 2 in front of the formula, and I get a total of 2 oxygen atoms. Okay, this isn't too bad, so let's look at some more examples. So how many of each type of atom are in the following? If we look at the formula on the left, KNO3, we see that there's an understood 1 subscript after the K, so that means we have 1 potassium atom. We see the same thing after the N, so there's also 1 nitrogen atom. After the O for oxygen, we see a subscript of 3, so that means we have 3 oxygen atoms. Alright, what happens when we put a coefficient of 3 in front of this formula? Well, now we're going to take the subscripts in the formula and multiply them all by the coefficient of 3. So that means there would be 3 potassium atoms and also 3 nitrogen atoms. And then we're going to take the 3 subscript after the O, multiply it by the 3 coefficient to get a total of 9 oxygen atoms. Alright, next let's look at some more challenging problems. So the question again asks how many of each type of atom are in the following, but notice in our formulas we have parentheses. We will have to treat the atoms inside of those parentheses a little differently than what we've been doing. I'm going to start with the formula on the left, MgOH2. we can treat atoms that aren't in parentheses just like we have been doing. So magnesium, Mg, is not in parentheses. It has no subscript written after it. So that means I just have one magnesium atom. The oxygen and the hydrogen are in parentheses, so I have to treat them a little differently. To count up the number of oxygens and hydrogens, I'm going to take their subscripts and I'm going to multiply them by the subscript that's outside of the parentheses. So for oxygen, there's an understood 1 subscript. I'm going to multiply that by 2, the subscript outside of the parentheses, to get a total of 2 oxygen atoms. I'm going to do the same thing for hydrogen. So since hydrogen is inside the parentheses, I'm going to take its subscript, which is an understood 1, and I'm going to multiply it by the subscript outside of the parentheses, which is a 2. So 1 times 2 means I also have 2 hydrogen atoms. Alright, let's try this again. So now we have the formula Ca3PO42. The Ca, calcium, is outside of the parentheses and it has a subscript of 3 after it. So that means I just have 3 calcium atoms. The phosphorus and the oxygen are inside the parentheses. So I have to take the subscript, multiply it by the subscript outside of the parentheses. So phosphorus, nothing is written after it. There's no subscript, so there's understood to be a 1 there. So I'm going to take 1 times the 2 subscript outside of the parentheses to get a total of 2 phosphorus atoms. Oxygen has a subscript of 4 inside the parentheses, so I'm going to take that 4 and multiply it by the 2 outside of the parentheses to get me a total of 8 oxygen atoms. Now, if there were to be a coefficient in front of a formula that contains parentheses, the same rules apply. So let's do an example. Let's say there was a 2 in front of MgOH2. What that would mean is I have essentially double the number of atoms that I calculated when there was just 1 MgOH2. So that 2 coefficient would mean I have 2 magnesium atoms, I would have 4 oxygen atoms, and I would also have 4 hydrogen atoms. Okay, I hope this helped with counting atoms in chemical formulas. Take care and be well.